So our topic for today is all about doubly reinforced beam. Okay. So so what is the purpose ng doubly reinforced beam? Paano natin masasabi na under doubly reinforced beam yung beam natin? So usually, naglalagay tayo ng mga compression steel bars dito sa compression side natin. So instead na yung bakal natin is nasa tension side, wherein yung main purpose kasi ng bakal natin is naglalagay tayo ng reinforcement dun sa tension side. Kasi, yung konkreto natin mahina sa tension, tapos yung steel natin malakas siya sa tension. Kaya naglalagay tayo ng tensile reinforcement on the tension side. So, bakit tayo naglalagay ng compression steel bars on the compression side? Sir, bakit po tayo naglalagay? Kasi nga, yung ginagawa natin sa singly reinforced beam is as much as possible, pinapayield natin yung bakal natin on the tension side. So, ginagawa natin is under reinforced design tayo under SRB. So, yung main goal natin is masira yung bakal natin on the tension side. Siya muna yung masira bago yung konkreto natin. So, sir, ano yung ginagawa natin kung sakaling hindi mag-yield yung bakal natin on the tension side? So, either gagawin natin is lalakihan natin yung cross-section ng biga natin. So, kapag nilakihan natin yan, so there is a possibility na mag-yield na yung bakal natin. Or, I might say na mag-yield na yung bakal natin once na lalakihan natin yung cross-section natin. Pero, bakit hindi natin nilalakihan yung cross-section? Para mag-yield lang yung bakal. Kasi unang-una, uneconomical yun. At the same time, magkakaroon tayo ng problema dun sa architectural. Kasi mangyayari is baka kakain ng malaking espasyo yung beam natin. So meaning to say, baka mahirapan tayo sa mga clearances ng bahay natin and many other architectural reasons. For that sake, instead na lakihan natin yung cross-section natin, why not we will going to put a compression steel bars on the compression side. So with that, so meron tayo ditong bakal ngayon on the compression side. So let us denote that as AS prime. So kapag may nakita tayong prime, meaning to say, ito yung sa compression steel bars natin. With that, same lang naman ng functions natin, no? Yung mag-iiba lang naman sa stress diagram natin is magkakaroon tayo ng strain natin sa compression steel bars. So for this one, let us denote that as eto yung strain natin sa compression steel bars. So with that, from the center of your reinforcement dun sa compression steel bars to the outermost fiber ng compression side natin, ito yung tinatawag nating D prime. So meaning to say, from the neutral axis, ito yung neutral axis natin denoted by this dash lines. So from this point, yung distance ng strain natin hanggang sa neutral axis, that is equal to C minus D prime. And kung titingin naman tayo dito sa force diagram natin, siyempre, ito yung analysis natin sa singly reinforced beam. So, yung tension natin dito, this is T. So, naka-align siya dito sa bakal natin. And we have yung compressive force natin na merong height na A, or yung A natin, that is the height of your compression block. So, sabi nga ni witness, instead na C, diba? Tapos, pa-curve pa yung stress diagram natin. Why not na magkaroon tayo ng equivalent stress block, which has an intensity of 0.85 F'C. So, yung resultant ng block natin na to, which is applied on this section, which is denoted by A sub C, that is equal to 0.85 F'C. So that is the intensity multiplied by the area of our compression. So that is equal to etong height na to, this is equal to A multiplied by B. Ngayon naman, what will be the contribution nung steel natin dun sa taas? So that will be a compressive force. So magiging compressive force ngayon yan. So mangyayari is magkakaroon tayo ng another compressive force here. So that will be, sabihin natin this is C sub 1. Sabihin natin C sub 2 pala. And yung C sub 1 natin is yung compression force natin dito sa sinking natin. So dito naman, mangyayari niyan is what is the value of your compressive force due to the steel itself. So that is equal to AS prime. Siyempre, meron tayong force, meron tayong pressure multiplied by area. So magkakaroon tayo ng force. AS prime, so this is the area. Tapos yung pressure natin, that is FS prime. So, from the location of your steel bars hanggang dun sa outermost fiber ng beam natin, that is equal to D prime. So, kung magkakaroon tayo dito, magkakaroon tayo ng distances between the compression steel bars to the tension bars, so that is equal to D, kasi from the center of your reinforcement to the outermost fiber of your beam, that is D, minus D prime. So, that will be the moment arm nung tension side natin at saka nung C natin. This will be equal to D minus D prime. So, ngayon yung analysis lang naman natin dito is simple lang naman. So, yung analysis natin dito, same principle lang tayo sa singly reinforced beam. Ngayon, mag-derive na tayo ng mga formulas natin for strain dito sa compression steel bars natin. So, denoting, diba, yung strain natin, that is yung modulus of, that is the stress over yung modulus of elasticity natin. So, with that in mind, so yung ES prime natin, so that is equal to yung Fs prime natin over the value natin na 200,000. So with that, if we will going to refer to the stress diagram, to the strain diagram pala, so again, I stand corrected, this is the strain diagram, this is the stress diagram. So if we will going to refer to the strain diagram, so mangyayari niyan by similar triangles. So let us consider the big triangle muna. So we have C over yung base natin dito na 0.003 is equals to, so yung height natin dito sa another triangle natin na maliit, that is C minus D prime over yung epsilon S prime natin. Wherein yung epsilon S prime natin, that is equal to Fs prime, is equal to Fs prime over 200,000. So with that in mind, kung aayusin natin to, mangyayari niyan is magiging C over 0.003 is equals to, so C minus D prime, tataas na ngayon yung 200,000 over Fs prime. So, kung aayusin natin yan, mangyayari niyan is magiging ganito yung Fs prime natin. So, the value of your Fs prime, that will be equal to 600 multiplied by, so, interchange lang natin. No? Ito, multiplying 0.003 multiplied by 200,000, you will have 600. Multiplied by C minus D prime. And then, pag interchange lang natin yung dalawa over C. So, this will now become your formula in computing for your actual stress dun sa compression steel bars natin. So, dun naman sa tension steel bars natin, yung formula natin is ano pa rin? So, pagkuha ng F sub S is ganun pa rin. Katulad nung sa nauna natin for singly reinforced beam, wherein F sub S that is equal to 600 D minus C over C. So, sir, paano po yung analysis dito? Same lang tayo dito, no? Yung analysis natin, that will be summation forces horizontal dito sa ano natin, dito sa diagram natin na to. So, summation forces horizontal lang tayo. Horizontal is equal to 0. So, mangyayari niyan is papunta doon. So, we have C1. So, yung compression equals tension tayo. Compression is equals to tension tayo. So, compression minus tension is equal to 0. So, compression is equal to tension tayo. So, sa compression natin, we have C1 plus C2 is equals to T. So, ano yung formula natin in computing for the value of your C1? So, that will be 0.85 F prime C AB plus. So, yung C2 natin, that is equal to AS prime. Tapos, yung FS prime natin, that is either FS prime, kung hindi nag-yield yung bakal natin, or FY. Okay? Is equal to, yung T naman natin, that is equal to AS FY. So, yung goal kasi ng doubly reinforced beam natin is mag-yield yung bakal natin sa ilalim. That's why, yung FS natin dito, that is equal to FY na. Okay? So, meaning to say, dito sa part na to, kapag nag-yield yung compression steel bars natin, FS prime, that is equal to FY. So, ito yung general formula natin in computing for your doubly reinforced beam. So, kung naiintindihan ninyo yung singly reinforced beam natin, hindi kayo mahihirapan dyan. With that, so kung magkakaroon tayo ng summation moment naman, so let's say, we will going to have summation moment. So, sa pag-moment pala natin, sa pagkuha ng nominal moment, lagi kang nag-moment dapat dun sa tension na lang. Okay? So, mangyayari niya, let's say, na clockwise is positive. So, dito tayo mag-moment sa tension side. Clockwise is positive. Yung nominal moment natin, rotation niya is clockwise, minus etong mga compression steel bars natin. So, you have C1, yung moment arm natin, that is D minus A over 2. Minus, yung rotation ng C2 natin na counterclockwise. So, you have C2 multiplied by D minus D prime is equals to 0. So, kung aayusin natin yan, so you will have nominal moment is equals to C1. So, transpose natin yung C1 at saka C sub 2 dun sa kabilang equation. So, ano yung formula natin for C1? That is 0.85 F prime C AB multiplied by D minus A over 2 plus the value of your C2. So, that is AS prime. So, di natin alam dito, FS prime natin kung FS prime ba yan or FY. It depends kung mag-yield ba yung bakal natin dyan or hindi. Multiplied by yung moment arm natin na D minus D prime. So, this will be your general formula in computing for your doubly reinforced beam. And of course, yung pagkuha ng ultimate moment capacity natin, that is reduction factor, multiplied by the nominal moment capacity. So, ito yung mga general procedures natin, Ito yung mga general formulas natin sa pag-solve natin or sa pag-analyze natin sa doubly reinforced beam. Sir, ngayon, tanong naman is, paano po yung mga procedures natin? So, unang-una, pagdating sa board exam, hindi ibig sabihin na meron tayong bakal on the compression side is agad-agad na doubly reinforced beam yan. baka display lang yung bakal natin sa compression. So first step, you need to check if real DRB ba yung sinosolve natin. So paano po natin i-check yan? So you just need to compute for the value of your raw actual and i-compare natin yan to the value of your raw maximum. If your raw actual is greater than to the value of your raw maximum, therefore, doubly reinforced beam yung approach natin. And after that, we're going to have an assumption for step number 2. So, magsi-C is equals to T lang tayo. We will going to assume that your compression steel bars will yield. In this manner, no, yung tension steel bars natin, automatically mag-yield na yan. Kasi nga yung purpose ng DRB natin, naglagay tayo ng compression steel bars sa taas for the sake na mag-yield yung bakal natin sa baba. So with this, a-assume natin na compression steel bars will yield. So dito, mangyayari niyan is the value of your Fs prime is equals to Fy. And siyempre, sabihin na rin natin dito na Fs is equals to Fy. And for the checking of assumption naman, mangyayari niyan is you will going to find the value of your Fs and you will going to find the value of your Fs prime. So eto, for the sake of discussion lang or checking, pwede ninyong i-check yung value ng F sub S natin, tsaka value ng Fs prime natin. So if your Fs is greater than to the value of your Fy, meaning to say, tension still yields. Kapag naman yung Fs prime natin that is greater than to the value of your Fy, meaning to say, compression still yields. So ganun lang yung mga general procedures natin dealing with doubly reinforced beam.